And Ellie, in this beginning section, if you could monitor the chat window, because I think there may be some questions that come up that, that we might want to address. And any of you feel free to ask questions as we start all of this, because I know that there's a bunch of things that we want to prepare for. So I think it's 11 o'clock, so I'm going to go ahead and start the class, and I'm going to share my screen because we have quite a bit of information that we want to cover today. There we go. So you should see what we're going to cover today in today's presentation, and you can see it's a long list. I want to start by talking about exam preparation. We'll then move on to the project, give you a couple of comments on stage 2, and then we'll talk about the things that are happening on stage 3, and then you'll have some time to meet with your groups before I finish by just talking a little bit more about the things that are going to be happening next week, and in particular what happens after the exam. So I want to start with this picture. And most of you will recognize that this is a picture of cheesecake. And the reason I'm showing you this picture is it relates to preparing for exams. And there's a story that goes with this. So when I was an undergraduate, I was living in a fraternity, and there was a bakery called Rowinski's Cheesecakes. And Rowinski's Cheesecakes had made cheesecakes that looked about like this. I think they were about 5-pound cheesecakes, so they were fairly large. And this was a long time ago, so a cheesecake only cost about $12.50. So that would be about the same as, let's say, $50 to $60 now. And Rowinski's had this offer that if anyone could eat an entire cheesecake within an hour, you would not only get the cheesecake for free, but they would give you $25. And that $25, you can consider that to be like $120 now. So that was a pretty big prize. So there were a bunch of us, a bunch of my people in my fraternity.
You want me to back in later? Yeah.
There's somebody that's not on mute. Okay, so so then a group of my fraternity mates decided that this would be an easy way to make money. So they worked out 5 pounds, basically how much room that would take in your stomach, and they practiced, and they said that shouldn't be any problem. They practiced with water. We should be able to do that very easily. And a 5-pound cheesecake is basically 16 pieces. So about 5 or 6 of my fraternity mates went over, and they were going to go win this competition. They came back a couple hours later, white faces. None of them could even eat half of the cheesecake. The most that anyone was able to eat was 7 pieces out of the 16. So what was the problem? The problem is that a cheesecake is too rich. Something that is really good is not something that you can necessarily consume those kinds of quantities all at once. And it's the same with preparing for an exam. That if you try to prepare for an exam by trying to cram everything and trying to learn everything all at once won't work. What you need to do, somebody else needs to go on mute, is to take this in bite-sized pieces. And so as you prepare, I recommend don't try to do all the studying all at once. Do it in pieces and just start learning things one step at a time, and you will do far better. And that's not just for this exam, that's for any exams that you take. All the studies show that that is fundamentally the better way to learn things. So let's go through some other things related to how to prepare for this particular exam. So as I mentioned previously, there will be 3 types of questions on this exam. You will have some kind of a calculation question. You will have some kind of a question where
Easiest class I've ever taken in my whole life, bro.
and you'll have some kind of other question
I
that you
just
might
have
have
you,
as
bro.
well. So as you do this, you think about these three types of questions. And last night, as a part of the announcement that you received, I attached a sample of what the exam might look like. It'll have about that many questions. It'll be printed, it won't be a PDF. So you'll actually get a paper copy of the exam, and then you'll write all your answers on that paper copy of the exam, and you'll turn it in at the end of class. So it's going to be very much kind of like a classic way of doing this. And you'll have questions in those three groups. So let's go through some examples of those three questions. You can bring one sheet, both sides of notes, right? So an 8.5 by 11 sheet of paper. It must be handwritten, and you will turn it in with your exam as well, so that way I know that it's both of them are in your handwriting. You cannot use a calculator, you can't use your phone, you can't use anything else that you might use to communicate with, and you won't need to either. So the exam questions, one type will be what I call a calculation question. And in Monday's class, I actually showed you this question. And then for the homework last night, I asked you, do you have any questions you have about how the exam will work? And there were a couple that I want to highlight because they're fairly common and I want to make it really clear. So one of them is, do we have to know the conversions? And the answer to that is there are certain kinds of conversions that I would expect you would just know, not because you learned it in this class, but because they're just things you should just know, like how many hours there are in a day, how many days there are in a week, how many how many seconds there are in an hour, things of this nature. You should basically already know. It's the kinds of things that are in common knowledge. You also need to know some of these prefixes, not all of them, but you need to know that there are 1,000 watts in a kilowatt, that there are 1,000,000 watts in a megawatt. You don't need to know giga or tera or anything beyond that. And you also need to know milli and micro, right? So milli is 1/1000th and micro is 1/1,000,000th. Other than that, I will always give you the conversion. So if you need to work out how many joules are in a kilocalorie, I will give you that conversion. Now there's a little bit of one of these that I would expect you to know because it's just seconds in an hour and watts in a kilowatt, and that is the conversion from joules to kilowatt hours. So we did that sample calculation in class once, and you should be able to do it based on conversions that you know. Another good question that somebody asked is, would you please explain how the calculations work if we are not allowed to use a calculator? So I'm going to explain this by showing you an example of the kind of calculations that we've been doing in class. Sometimes you've had it for homework, sometimes I've given them as examples. So I would give you the information that's up on top here, right? So things like what the cost of things might be. I would give you some key other information, and then I would expect, based on that you would be able to set up the conversion, the calculation that would go into a calculation like what you see in the blue as these ratios down below. You don't need to calculate the number in red that I'm showing you here, but you must have these ratios set up completely correctly so that if somebody were to plug that into a calculator, you would be able to get the right answer. So do any of you have any questions on that? If you do, put them into the chat box. And Ellie, if you could check and see if there are any questions about how that works. Okay, I assume that all of you understand that fairly well. So one of the questions you will have will be this kind of a calculation question. You will also have a diagram type of a question. And this is the example that you did in last night's homework. And as part of your review for this, let me show you an example of what is not the correct diagram. And I'll show you an example of what is a correct diagram. So what I'm showing you here on the left is a picture. What it shows is what the water flowing down from one place to another looks like. It does not include all of the variables. And just looking at that diagram, you would not be able to make any calculations from it. What I'm showing you here on the right is the kind of diagram that we're looking for. So it is something that would show the relationships that would actually allow you to make the calculations. Are there any questions on that and what the expectations would be?
I have a question, Bert.
Yeah.
So when you gave us the 10 meters cubed per second, I see that you just have it written down. Do we have to do anything with that number, or in the diagram, do we just have to mention it?
You should mention it just the way it's mentioned there.
Thank you.
Okay. And that 10 cubic meters per second turned out to be important for the question that I asked after this. And that question I asked after this, which was the multiple choice question, actually turned out to be more difficult for you than I thought it would be. So let's go there unless we have any other questions. So that question that was after that was this question of the energy that is the output from the generator, this electricity, I should say, the electricity that is the output from the generator. Is that electrical energy? Is that electrical power? And depending upon which of those it is, would that be measured in kilowatts or kilowatt hours? Or is it something else? Now that turned out to be a very difficult question for most of you, and the majority of you did not get it right. So first off, you can eliminate two of these very easily. And the two that you can eliminate is that energy is not measured in kilowatts. Okay, so A can be eliminated. And the same way, power is not measured in kilowatt hours, so that one can be eliminated. Okay, so that left you with B, C, and E. Now, the key thing to understand about the way that I described this, and I think it turned out to be a little more difficult than I had expected, and it's not my intention to make this more difficult, but there's a great learning opportunity here, and that is power is a rate and energy is a quantity. And when I gave you the information that said the water flows at a rate, what that meant is that the electricity also flows at a rate. And so that electricity flowing at a rate is actually power. So the correct answer for this one is C, electrical power measured in kilowatts. Any questions any of you have on that? Okay, do you understand what we're looking for? Do you understand how it works? Okay, then I'm going to go on. The next type of question that you will have, the third type of question, are what I call more of these critical thinking questions. They can cover anything that we have covered so far this semester. It doesn't require memorization, but I recommend that you review everything that we have covered so that you can provide an intelligent answer. And I've given a couple examples here. So one of them is, circle one of the majors, give an example of a job an engineer in that major might do that is related to addressing climate change, and identify one guest we've had who has mentioned this major and what you might have learned from that guest. Okay, so if you've been following everything in the lectures, you should be able to answer those questions. Another question, this one, I want you to...
There's a question about that.
Oh, okay, let's go back.
For the guest lecturers, do they have to know their names?
No, very good question. Okay, if you see it was the person who talked about this and he was, he showed this, as long as I can recognize which one you meant, I don't expect you to write down a list of names, because that's not something you need to remember 5 years from now. So if you don't need to know it 5 years from now, you don't need to know it for the exam either. Good. Any other questions on that? That's really a very useful one to understand, and it should help you in terms of how you organize your note sheet. So this one, I want to go back to, because this, I think, is a good, valid question. It's something that we covered in one of the lectures, and I'm going to do it now as an iClicker question. So which number in the following chart shows that increasing CO2 levels cause average global temperatures to increase? So go ahead and use your iClickers, and you may not be able to see that it's counting up, but I can tell you, it should now be open, and you should be able to use your iClickers to identify which response is correct. And then I've got 29 responses so far, so I want to make sure we get all of you have a chance to respond. And then then we'll go through it and make sure that you understand how to prepare logically for these types of questions as well. So I've got 45 responses. We'll give just another 30 seconds or so, and then we'll look at your answers, and we'll talk about how to do this as well. Okay, looks like we're not getting any others coming in, so we'll go look at the 46 answers that I have and go through those. So you can't see my little set of poll results, but we have 11 people who said A. We had 29 students who said C, and we had 7 students who said E. Now, E is correct on this. The reason that E is correct was this concept that we covered when we talked about correlation, regression, and causality. And the point that we made was that the fact that two things match on this graph, that they show this kind of a linear relationship, does not mean that one causes the other. There can be other reasons for that. There can be something else that relates to both of them that doesn't necessarily mean that those two, one causes the other. It just shows that there's a relationship between them. So that's a very important concept. I would expect you all to know it and to be clear on it. Do any of you have any questions on that?
The only question I have so far is this lecture going to be posted on Canvas?
Not only will the lecture be posted on Canvas, but I'm recording this. Okay, so you will be able to go through this. You have the other lectures primarily where we were face-to-face, you have them in Echo 360. You will have printed versions of all of the lectures as well. We want you to learn this and to understand it, and because we want you to do well. Now let me answer another question that somebody asked, and that is the exam curved? The exam will not be curved, because If you can get to knowing how to answer these questions, I would rather give all of you A's than to do any curving. So the questions will not be more difficult than these. They will be different, but they will be of a similar type. So think about how you can best learn these. If you have questions, feel free to contact me through the weekend because I want you to be able to learn it at this level and do well. Were there any other questions that came in? Okay, good. Then in terms of preparing for the first exam, as I mentioned, you could be in person or you could be in quarantine. If you're in person, we'll have a seating chart. I'll send that out on Sunday night. There will be an overflow room if we have more than 47 people, and we'll have somebody to proctor that overflow room as well. And as we mentioned, you can bring one sheet of handwritten notes, but no calculator, and you won't need that calculator because of the way the exam is structured and what you need to do. The exam will not be difficult to do all the questions in the time available. It's actually going to be shorter than last year. And last year's exam, there were students who turned it in within 20 minutes. So it's not that you're going to be pressed for time, but you are pressed for thinking through the questions logically. If you're in quarantine, you need to make sure you declare that by 8 a.m. Monday. So if you wake up Monday morning and you're feeling ill, don't come to class. But I need to know by 8 a.m. because I need to email you instructions for how the online exam will work. You must take the online exam. You can't say, I want to skip it. You've got to at least take it. That exam is tightly timed and has more complex questions. Not more difficult, but more complex because we can't allow you to have Alexa answer your questions for you. You must upload images of your handwritten calculations and your results as well as you do that exam. And only if you take the online exam will you have the option to retake it as an in-class exam. Your online exam will be scored, and then you'll have the choice to say, yes, I'd like to replace that, or no, I'm fine with the score I got. And so that will be the way it will operate. Any questions on that?
There's one question asking if we complete the exam early, do we have to stay in the room or can we leave?
No, you're done. Okay, so you can go have cheesecake. All right, so there are also 2 review sessions that the learning assistants will be doing. This was also in my announcements. From 2 to 3 is face-to-face. It's in Scott 229. It's just upstairs from where our lecture hall is located. And then there's also one on Zoom, and there's the Zoom link in case you want to do that one instead. I've checked with the learning assistants. Some will have some time to answer questions for you this weekend, but many of them are preparing for exams also. So if you're not getting a response from a learning assistant, feel free to, or you would prefer, feel free to email me, because like I mentioned all the way through, I want you to do well on this. Here you now have a good, clear idea of the kinds of things that you should be preparing and how I would recommend that you prepare. That's it on the exam. Quick comments on the stage 2 results. Those are posted. There's a PDF feedback sheet for every single group. You should be able to see that. If you can't find it, let me know, but it's there. Completeness, clarity, and quality of your specifications is one of the most critical things that you're working on. And as a result of the challenges that are involved in that, I also have created a video and I put a link to that video in the announcement last night also. And I really encourage you to go through that process and understand that. The reason that this is so important is if you don't have a good specification, your ideas won't encompass what your stakeholders are really looking for. And that's a bit like putting the cart before the horse. It doesn't actually work very well that way. And there's an example in the video that I've put together there also, which is when the Americans and Russians were in the space race. The Americans spent millions of dollars inventing a pen that worked in space in 0 gravity, and the Russians just said, we're taking a pencil, right? All they needed to do is write. So, and you've, on some of your specifications, I've given you feedback like that. So you've, in some cases, you've written your specifications around your ideas. That's the wrong way. That's the cart before the horse. That's not what we want to do. So that little video gives you a good process to make sure that you understand it better. You were not really marked down for the kinds of detailed comments I made on your specifications if you generally knew how to do it. But I recommend, as part of stage 3, you improve those specifications because it will help you significantly in how you can do the rest of the project. Okay, so I'll turn it over to Ellie because I need to get you in your rooms.
All right. So in stage 2, you identified your specifications, and in those specifications, I really told every single group to make sure you identify what units will be used to measure each specification. And if you were doing like a ranking scale, you had to define your ranking like number 3 has done. And to kind of elucidate where we're going from here, you're going to want to take your specifications, and then you're going to want to brainstorm ideas that optimize those specifications. You want to think of your specs as like a rubric. If you're grading a paper, you have criteria that you want to use to say, is this a good paper or a bad paper? Your specifications are going to do that same thing, but for the ideas that you brainstorm. It's going to be what gets an A, what gets a B, what gets a C. That's the purpose of the specifications. And so as you're coming up with ideas, that's the blue headers of the columns. This problem example is about solar panels. And so the problem is about optimizing the angle of solar panels in South Africa. And there were 3 options this group came up with. And one was that it's a fixed panel. That's all it does. It just sits there. And so that optimizes things like cost because there's less moving parts. But it doesn't optimize electricity. And in the next step that I'm going to explain, you'll figure out how to start identifying how much electricity it produces. Another idea is to keep it fixed, but it has a battery with it, which is nice because you can actually store electricity that you're not using right away. And so that'll increase cost, which would kind of be a negative for your specification, but maybe the pros outweigh the cons. That's what all 6 specifications are going to tell you. And so the approach is going to be similar for each of these panels. And then the last one would be a rotating one, also with no battery. That one has moving parts, so it's more complex. So that would also be more expensive than panel 1. But maybe by tracking the sun at all hours of the day, that would be more useful than just a fixed one. So that's the ideas that this group came up with for how to improve solar panels. 1, very cheap and effective option, keep it fixed. 2, put a battery on it so you can use the electricity at nighttime. Or 3, have it move so that the power is optimized at every time of day. And so since these are 3 different ideas of how to solve the solar panel problem, the first step for specification 1 is identify your problem statements, which I'll talk about in a second. And so that's what that angles and efficiency is. That's kind of a really quick summary of what the problem is going to be about. And then for the second one is going to be a cost analysis. And what that basically means is you're going to try to identify the materials that need to be used to build your solution. In this case, all 3 of them are solar panels. And so you're going to try to find information on how much each of the materials cost. And then you're also going to want to estimate the cost of labor as well. How long would it take? What are you paying your employees? You're going to want to think about those types of information as well for your cost analysis. And then for a ranking scale, you need to specify exactly which criteria you're using, including the definition of that criteria. So for number 3, panel 1 is the best option because electricity is always available. You can access it at night. And so in your project report, you're going to want to put it into a table format like this, where you have your specifications in the first column. And don't forget to identify the goals that you should have put in your stage 2 report. Those goals should be the same as the goals, or same or improved, I should say, from the last column in your specification tables from stage 2. So you identified your units and you're like, goal, I want it to be cheaper than, in this case, $300,000, plus or minus $20,000. And so you're going to want to put your attributes and you're going to want to put your goal into this first column. And then you have 3 ideas that you want to come up with because you're choosing one of the research topics that you identified. Let me back up for a second. So first, you're going to want to choose your project based on design project 1, design project 2. And then you're going to want to come up with 3 different solutions. And then for the specifications that you identified, you're going to want to identify how you're going to go about calculating those specifications, whether it's a design analysis, whether it's a cost analysis, or whether it's a ranking scale. And so with that, I'll take some questions before we talk about problem statements. Is there anything unclear with what this table needs? All right, seeing no questions, let's talk about problem statements. Let's go on to the next slide, please.
Ah, sorry.
All right, so for problem statements, this is a little different than just describing a problem. The mindset you want to think about this is, if I was a math teacher writing a word problem, how would I write this? Like a really basic example would be, Susie has 3 apples and Bernard has 10. How many apples do they have together? And your unit is number of apples, and your calculation is really clearly that you should add 3 plus 10 apples to get 13 apples. You want to think about a problem statement in that mindset. And so a problem statement where that would be really difficult, which is not really a statement, it's more of a background description, is in the left box. A problem is that human activities are putting too much CO2 in the atmosphere, which is creating climate change. That would be like an introductory sentence in a paper. That would not be in your methods section for saying, how much CO2 are we putting in? You're not identifying what needs to actually go into a calculation, and you're not identifying a unit that comes out of it as well. In contrast, a good problem statement would be like the one on the right for the solar panels that we just talked about. We talked about those 3 solution ideas with the fixed panel, with the battery, and with the rotating panel. And for each of those solar panels, a good problem statement would be, determine the optimal tilt angles for a solar panel in Johannesburg, South Africa, to maximize the solar energy collected during a year. And so some of the things that are going to be important with this is you need to know the latitude of Johannesburg. You need to identify the amount of solar energy collected, and you have a time frame during a year. And you have a very clear objective that the problem really is looking for a tilt angle of the solar panel. And so this would be an example of a good problem statement. Do you guys have any questions about this? Do you want me to come up with more examples? Give it a few seconds.
We can actually go to the next one.
All right, let's go into the next slide. Didn't we just talk about this?
No, this is a different one.
Sorry. Yeah, so another example of a problem statement that would need more work is determine the optimal technology that can be used to continuously monitor symptoms of COVID-19. Bit of an echo. This one is not good because you're saying determine the optimal technology, but technology doesn't have a unit. You need to identify a specific aspect about the technology that you are calculating. And so an improved version of this would be calculate the percent of cases of COVID-19 that will be missed at CSU by a technology that generates results instantly, but only catches 90% of cases. And so in this problem statement, you can see that you are calculating a percentage. You've identified your unit. That's already an improvement. And you're not trying to calculate a technology. You are trying to calculate a technology that has an accuracy of 90%. You've already identified that that's how good it is. And so this is a much better problem statement. It's clear what you have to do next.
And let me just say one thing there. This is difficult. So all of the things that we're covering today are difficult. So don't expect that you can immediately understand this. And that's why I've created those video tutorials to help you. And those video tutorials, if you go in Canvas and you go to the project module and you go into the overview, those two videos on the specifications and on the 7-step problem analysis are number 7 and 8 on that overview. So I really encourage you to go back, study them, look at them multiple times, and it will make more and more sense how that fits. And students every year have difficulty with this. That's why I created those tutorials, and it will help once you understand this. This is something that will stay with you for 5 years from now. So it'll be very useful. Anything, Ellie, you want to add before we go into our groups?
I guess just know that you can keep asking us for help. A lot of us have, especially the learning assistants, have done this before. Bert is going to be grading. He's always a good resource. And I am always happy to help as well. Just know that you're not alone. And one thing that will help with the questions is if you have watched these videos first. That way we're coming in from the same approach. But we are happy to help.
Do you want to cover this one, and then we'll put everyone in groups?
Sure. So for today, you are going to want to sign up for a meeting on Canvas like we've been doing. I've put them up for Friday and Monday, October 9th and 12th at 1 to 5 p.m. Just so you're aware of that. And you're also going to want to start identifying your task breakdown for your smart contract. And identifying who is the owner of each task. And so that's what you're going to do in your breakout sessions.
Okay, well, here you go. And we'll finish a couple minutes before. I'll give you like the 1-minute warning, and then we'll just make sure that we're set for next week and all your questions are answered.
Group 1 was happy.
Yeah, I didn't even tell you you're ready to pop wherever. So you can feel free to pop around if you like. I think we did it well today.
Yeah, I still don't know how to change breakout rooms. I've never figured this out.
In breakout, you have this thing called breakout rooms somewhere at the bottom.
Yeah, it just doesn't give choices. It just says you have been assigned to breakout room 1, join breakout room, or close.
You want me to send you somewhere?
Sure.
Okay, here you go. I think what I'll do is I'll just, here you go, you're in 2.
All right.
You have to go there.
Oh, I was waiting for the pop-up.
You want to go somewhere else?
Sure.
Okay,
They're pretty happy.
well, we'll just keep popping you.
All right. Perfect.
Okay, ready for the next one?
Yep. They're all just figuring out meeting times. They have
Yeah.
to pick different ones, so I guess it's taking longer.
Yeah, you messed up the system.
All right. Breakout 4.
Okay, you ready for 5?
Yep. All right.
Looks like 5 must have had a question for you.
They were asking about the meeting minutes, and I was like, that was my bad.
Okay.
All right.
Hi, Bert.
Hi, how you doing?
Good. So we're having a little bit of trouble finding the feedback for stage 2.
Okay, so none of the 3 of you could get there, huh?
Well, so the way you did it for stage 1 was in the grades. It was like a comment on the side, and it was a PDF. And
Yeah, this should be the same.
there isn't a comment on it that says there's just conversation between you and Ben, and that's it.
Okay, that's weird. It should have been there at the bottom. So that is your, which group are you?
I think we're 14.
Yeah, so what I'll do, because I won't have time to do it here until class finishes,
Mm-hmm.
I'll follow up, check my own work, make sure it's there,
Okay.
and then whether it is or not, I'll just mail it, I'll email it to all 3 of you too.
Okay, that sounds great.
Okay, so then you're well covered.
Okay. If you could just throw me back into the breakout room.
You throw yourself back.
How do I do that?
I think there's something like breakout room and you just click it. Down at the bottom, maybe a more
Oh, here it is.
that room.
All right.
Okay. We'll bring everyone back and we'll do just a quick overview of what next week looks like. Okay. All right, welcome back, everyone. What I want to do is just make sure that you have an idea of what's going to happen next week, in particular after the exam, and the things that you can expect that will be going on. So you have the exam on Monday. We've talked about that. There's no homework this weekend because you're preparing for the exam. There'll be a small homework assignment for Tuesday night. We'll have a guest speaker next Wednesday, so class will be normal face-to-face, kind of similar to last Wednesday, but a very different kind of a guest speaker in terms of what he's done in his engineering career. Then you'll have a homework assignment next Thursday night, and then next Friday is going to be on Zoom again. And the reason that next Friday is on Zoom is we'll have a number of tests that will all be and you'll be broken up into groups to talk about different majors. So we'll have grad students in various different majors. So you'll meet the graduate academic coaches and some of Ellie's peers in various different majors. And they will talk about what they've been doing, and you'll have an opportunity, kind of like in your small groups here, to ask them questions about why they chose that and various other things that are of interest. So that's it for today's class. Any of you that have questions that you'd like to talk to me about, I'll hang on for a little bit afterwards, and I'll be happy to answer any questions. And otherwise, feel free to log off, and good luck as you prepare, and we'll see you on Monday.